Hello students, welcome back to the next session. In this session, we'll be starting with the new chapter, that is inheritance. This chapter carries a total of 5 marks and you will have one question for 5 marks. This is about it. Now, before starting to inheritance, let us know what an inheritance is. We are talking in terms of biology. Inheritance means you might have heard people tell you that you look like your father, you look like your mother, you look like your grandfather, your eyes are the same as your brother, the shape of the nose, mouth, etc. Right? So, this is what you are getting, the genes which have been transferred from your parents to you. So, that is, you have inherited some of the characteristics of your parents. In terms of biology, that is known as a inheritance, genes. Right? In the same way, even in programming, inheritance allows us to define a new class. It allows us to define a new class using the properties of pre-existing class. Using the properties of pre-existing class. Why are we using this? Because it makes it easier for you to create and maintain any application or programming. And it also provides you an opportunity to reuse the code and it will be faster. These are the advantages of using your inheritance. So you know now what an inheritance is. Inheritance means it is nothing but the process of generating a new class by extracting or getting the properties from the pre-existing class. This is what you call it as inheritance. Now, you are supposed to remember two terms when you're talking about inheritance. So, new class, right? This new class will be known as your derived class. The new class will be known as your derived class. And the pre-existing class will be known as your base class. That is, the class from which you are inheriting is your base class. So these are the two definitions that you are supposed to remember: base class and derived class. Now, we already told you a few. What are the advantages of inheritance? Sometimes they may ask you this question for 5 marks. As we said earlier, one of the advantages is code reusability. You can reuse the code. And testing and debugging. Testing and debugging is easy. Testing and debugging is easy. And then coding is easy, because you need not write the entire program once again. Only whichever is important, which is not there earlier, only that can be written. So coding is easy. And objects can be represented in different levels. And it has an efficient memory utilization. And most important, faster development of codes, and it is easy to extend the program also, and because of all these things you have easy maintenance also. So these are the advantages of having your inheritance, that is code reusability. That is, as you have created a code once, you can make use of the same code in some another program, or if necessary in the same part of the program, some other part of the same program also. So code reusability is one advantage. Testing and debugging is easy because you have already created one program, you have used it, you have tested it, everything is done. So if you are going to make use of the same part of the program in some another program, and you are going to extend it a little bit, add some more lines to your program, so your testing can be done only for that part which you have added now, because the earlier program is already tested. So testing and debugging is easy. Coding is easy because you're going to go for part by part. One part is got from here, one part is got from somewhere else, so it becomes easier. Efficient memory utilization, because you are saying you need not store the space again and again for the programs. We are saying we are reusing the code, so one part of the program is there in one place. For example, this is one part of the program, it is there in this place. So you have another part of the program in this place, you are creating a new program C. So this may contain some programs of A, some programs of B, and some of its own C. So here what happened, instead of writing the bigger program for this C, you can get it from A, that is function, using function call. You can get it from B. So this much of space again which A and B were supposed to occupy is reduced now, because it is there already stored. It is stored already, right? So instead of writing it once again, you can call it from there itself. So an efficient memory utilization. Faster development, as we said again, yes, you already created, you are reusing it, so it is a faster development. Because of all these, it is easier to maintain the programs. All these are your advantages of your inheritance. Now how are you going to define an inheritance? You give the keyword class and give the derived class name, and then remember, this is not a scope resolution operator, it is just a single colon, and then visibility mode and base class name, and then access control specifier, data members, and member functions. This is how you are going to define a class. In this semicolon signifies that it is a derived class, that is derived class inherited from the base class. The access control specifier or the visibility mode explains the scope and the access permissions of for different functions and data members of in the derived class. And the visibility mode also tells the base class members, that is how it is going to appear in the derived class, if it is private, public, or protected. This is done in your visibility mode. Now coming to the most important part of this chapter, that is types of inheritance. This is the most important 5-mark questions from this chapter. Types of inheritance. What are the different types of inheritance that you have? There are totally 5 types of inheritance, and in this 5 types of inheritance are all important because they can ask you directly a 5-mark question from this. This is the most common 5-mark question you get from this chapter. We'll explain the different types of inheritance. So, which are the types of inheritance? You have single level inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, and hybrid inheritance. Remember, when using all these types of inheritance, diagrams are compulsory. Diagrams is a must. You have to explain using your diagrams, and do not get confused between multi-level inheritance and multiple inheritance. Have a clear mind. Now let us first go for your single level inheritance. Single level inheritance. Now what do you mean by this single level inheritance? Single level inheritance means that you are going to create a new class by inheriting the properties of the base class. That is common in every types of inheritance. That is acquiring the properties by inheriting it from a base class, base to derived class. But one thing that you are supposed to remember is you have one base class. Okay, this is your base class, and you are going to get this derived class from the base class, right? But there can be only one derived class here. You cannot go further. This is not allowed. Only one derived class. That is, for example, you have a base class as vehicle, and a car is a vehicle. So only this much. There is nothing else here. So this is what you mean by your single level inheritance. Only one base and only one inherited or derived class. One derived class. This is what is known as your single level inheritance. In multi-level inheritance, it is the opposite. You do not have much in this, only this much. It is a type of inheritance in which a class is derived from an already derived class. Okay, that means that you can have as many derived classes as possible. That is what you mean by your multi-level inheritance. For example, you have a base class, right? And you have a derived class. This is one derivation. Again, you can have one more derived class here, derived class 2. If you want, you can have one more derived class here, derived class 3. So many derived classes but one base class. You can have as many derived classes as possible but from a single base class. Now for example, if you want to give a example, electronic device. It is a base class. Okay, so derived for this, your computer is an electronic device, right? And again, your CPU is an electronic device. Your register is got from CPU. CPU is got from the computer. Computer is an electronic device, right? So this is an example for your multi-level inheritance. That is, you can have more than one derived class. Next, class is your multiple inheritance. Multiple inheritance. What do you mean by this multiple inheritance? In this, a new class is derived by using the properties of two or more base classes. Two or more base classes makes up your derived class. This is what you mean by your multiple inheritance. Okay, so the figure for this you'll understand much easier with the help of a figure. Now you have one base class, you have one more base class, you can have more also, and then you are getting a derived class from this. This is your derived class. Okay. Now, if you're going to go for an example, we say you have your, for example, for the science student, you have your PCMB is one of the combination base, is PCMC, PCME, PCMS. This is just an example I'm giving you. This is your science class. A science student, science can contain either PCMB or PCMC or PCME or PCMS. In the same way, if you go for your commerce, it can either be your HEBA or EBAS, EBACS for commerce, anything. So this is what, if you have got more than one base classes and you have got one derived class, we call it as your multiple. Remember, multi-level and multiple. This is what you mean by your multiple inheritance. So let us stop now and continue in the next session.